The next topic that we will talk about is radian measure. Radian measure is basically another way to measure an angle in another unit. We can think about a similarity that we're used to. In America, we measure distance in miles. Okay, in Europe, they measure distance in kilometers. So they are both a measure of the same kind of thing, distance, but we use different units. Okay, the same thing can be said about radians. All right, first of all, how do you create this unit called a radian? We understand how we create degrees. In other words, if we take and we rotate a full rotation, that becomes 360 degrees. This is something we're familiar with. We understand radians. We need to start with a definition so that we know what 1 radian represents. Okay, we start this definition by creating an angle by using an initial side and a terminal side. Okay, we take a certain amount of rotation, and there is our angle. It turns out that 1 radian occurs when the distance from the origin out to wherever you start your rotation, let's call this R1 for a radius, is equal to the distance from that point where you start rotating all the way up to your terminal side. That distance is going to end up being what we call an arc length. Let's call it R2. So what we're going to say is we're going to say that theta equals 1 radian when those two R values are the same thing. R1 is equal to R2. In R1, it turns out, is totally irrelevant. In other words, you can have R1 being a small radius, and what that means is that means you're going to rotate a small amount to get your theta value, and so R2 will also be small. And then R1, if you make it a bigger number, then obviously R2 will also be a bigger number. And so the actual lengths of R1 and R2 are irrelevant. The only thing that makes a difference is that you have achieved 1 radian when the two values of R are equal. Now, that being said, I'm going to go and write down for you some of the basic radian measures to know. So basic radian measures to know. All right, the first of these, I'm going to write down conversions for quadrantal angles in degrees to radians. Okay, the first quadrantal angle in degrees is 0 degrees. Okay, that's equal to 0 radians. Now, something tricky about radians is this. It's not incorrect to write 0 radians, but y'all can see that after a while, writing the radians is going to become tedious. And so what has happened is, if you have a unit on your value, 0 degrees, it's obviously in degrees. If you have no unit, in other words, if we just say 0 by itself, then that 0 is understood to be in radians. The next quadrantal degree measure we have is 90 degrees. Okay, you see that the units are on that, so it's obviously in degrees. That, it turns out, is equivalent to pi over 2 radians. You see that there are no units measured on that, and so it would be understood to be in radians. The next one around is 180 degrees. That ends up being pi radians. Then you have 270 degrees, which ends up being 3 pi over 2 radians. And then all the way around, you have 360 degrees is equal to 2 pi. Now, so far, with the radian measures that I have up here, you can count by pi over 2's. Do y'all see that the first one is obviously 0, and then you have 1 pi over 2 being 90 degrees. Well, what's 2 pi over 2? 2 pi over 2 is the same thing as pi. That's 180 degrees. And then you go around again, you have 3 pi over 2. That's 370. And then you go around again, and that's 4 pi over 2. 4 pi over 2 is the same thing as 2 pi. So if you go by 90-degree measures, then you see in radians you're counting by pi over 2s. There are also some basic radian measures that you need to know that are in the first quadrant. There are also more in quadrants 2, 3, and 4, but we'll talk about those at a later date. The first one that I need you to know is 30 degrees. Okay, 30 degrees in radian measure is pi over 6. The next one is 45 degrees. 45 degrees in radian measure is pi over 4. And then the last one in quadrant 1 is 60 degrees. 60 degrees in radian measure is pi over 3. The way I remember these, do y'all see that 45 degrees is exactly half of 90? 90 degrees is pi over 2. A half of pi over 2 is pi over 4. The 30 and the 60, I just use a trick. In other words, do y'all see that the 30 goes with pi over 6, the opposite of what you would think. And then 60 goes with pi over 3, the opposite of what you think. Those two are just tricks, but it helps me remember. Now, as far as your actual conversions, let me write these two things down. Okay, so conversions that you need to know. Number 1, if you want to go from degrees to radians, what you're going to do is you're going to multiply by what we call a clever 1. You know that multiplying by 1 doesn't change anything. But if our 1 has the proper units on it, we can convert from degrees to radians. Okay, if you have degrees, then you would need to get rid of your degree symbols. So what we're going to do is we're going to multiply by something over 180 degrees. Okay, the degrees on the bottom would cancel out with the degrees that you are already given. 180 degrees is the same thing as how many radians? Pi radians. Okay, this happens to be the units or the conversion that we do to get us from degrees to radians. Okay, number 2, let's say we want to get from radians to degrees. You're going to do the opposite thing. You're going to multiply by something over pi. Pi, because it doesn't have a unit on it, is radians. Okay, so that would get rid of the radian measure that you already have. You want a degree measure in it, so we'll put the 180 degrees on the top. Okay, let's do two problems like this. So first of all, let's say that we want to convert, and let's pick something halfway decent here as far as a number. Okay, we want to convert, let's say 140 degrees to radians. Okay, I'll take the 140 degrees and I'm going to multiply by the proper conversion unit. Y'all see that from above, that if I want to get from degrees to radians, I multiply by pi over 180 degrees. That makes sense because if you do that, put pi on top and 180 degrees on the bottom, you see that your actual degree symbols cancel out. Okay, and so what you end up having is you have 140 over 180, and I'm going to put the pi out to the side. Now the reason I'm doing that, the pi in radians normally stays just pi. Okay, it's an irrational number. We don't want to change that to a decimal. Now on the calculator, you can take and you can tell it to reduce 140 over 180. This reducing is something that you could do by hand very, very easily, but for bigger numbers or things that you don't want to spend the time converting, your calculator can do this. Okay, so on the calculator, to reduce, you're going to type math, frac, and then enter. That will take whatever your fraction is, and it will reduce that 140 over 180 to a smaller value. And so if you do that, that smaller value ends up being, I believe, 7 over 9 pi. Okay, and this would be your answer. You see that there's no units on this answer. Because there's no units on this answer, it's understood to be in radians. If for some reason you forget and you leave the degree measure on this, the answer is wrong. In other words, 7 over 9 pi degrees is not the same thing as 7 over 9 pi radians. So make sure that your degree symbol disappears. Okay, let's do another one, but let's do it the other direction. So let's say here we want to convert, and on this one I would like to go and use 2 pi over 3, 2 degrees. You see that the 2 pi over 3 doesn't have any units on it, so it's understood to be radians, and so we want to take these radians and we want to convert them to degrees. So your 2 pi over 3 needs to be multiplied by something so that you get degrees back in the problem. So the degrees need to go on the top, 180 degrees. Your pi wants to go on the bottom. A lot of the time, your original radian measure is going to have a pi in it. It does not have to, but in this case, because the original had a pi in it and you're dividing by a pi, you see that those cancel out. 2 times 180 is 360. Make sure you now keep those degree units divided by 3. And then 360 divided by 3 is 120 degrees. Okay, the final thing that I want to discuss here is I want to discuss making sure that you use the proper symbols. Okay, so make a note. If you happen to go and, let's say on an exam, you leave a unit you shouldn't leave. So in other words, you're going along and you have 5 pi over 7 and you mean radians, but you accidentally put degrees, make sure you know that's not equal to what you really mean, 5 pi over 7 radians. Okay, the degree symbol here makes the actual value a different value from the 5 pi over 7 radians that you mean. Okay, also make sure that you know that radians don't necessarily have to have a pi in it. So in other words, if I say 102 versus 102 degrees, this 102, because there's no units, is understood to be in radians. You wouldn't necessarily know it's in radians because there's not a pi with it. It's okay, it doesn't have to have a pi with it. You know it's in radians because there's no symbol. This one over here you know is in degrees because of your symbol. Okay. This concludes our lesson on radians.